So this is about how a hard drive works. So yes, on the left we have the world's first IBM hard drive. This was informed by Jacob Rainbow's ideas at NBS. IBM developed and shipped the first commercial hard disk drive, HDD, also known as the Model 350 disk storage unit, to Zeller Batch Paper, San Francisco in June 1956 as part of the IBM 305 Random Access Method of Accounting and System. So yes, the only first. Guess what? This is only 1.2 billion bytes. So this is equivalent to, well, about roughly 1,200 megabytes. And to put that into comparison, 1 gigabyte is roughly only 1,000 gigabytes. So this huge thing only had a storage capacity of 1.2 gigabytes. In comparison, this is a 2 terabyte hard drive. And to put that into comparison of size-wise, this you could fit roughly 1,000 of these 2 terabyte FireCuda hard drives into the same space of that 1956 1.2 gigabyte hard drive. To put that into comparison, this is roughly 1,500 times smaller than this, even though it's up to 1,000 times bigger than the Seagate drive. So now, how do they even work? So now, they have something called, they have used bits. Bits are also known as binary. So yes, these are known as ones and zeros. And a bit, short for binary digit, is the smallest unit of data in a computer. A bit has a single binary value, either of 0 or 1. Half a byte, 4 bits, is called a nibble. In some systems, the term octet is used for 8-bit unit instead of a byte. In many systems, for 8-bit bytes or octets form a 32-bit word. So yes, a bit is basically ones and zeros. And how do they take place? Either there's a charge, which is a 1, or there is no charges, there's no electric signal at all, which is known as a 0. And what does a hard drive do is that it takes all these, and by knowing that, is that let's say the up arrow with the red is the 1, and the one which is bottom is the 0. And how do these ones and zeros make up video games, a picture, How does it even make up this picture? How can a bunch of ones and zeros make up this picture? It's really simple. It's kind of like words. A, B, C, D, E, F, G. They don't make sense by itself, but when you put them together, they can form letters like hello, save the world, royale, creative, game, mode. Because when you put them together, it makes sense. And these only make sense to those who speak English. But this is the same for computers. For us, it does not make sense. But to computers, this makes sense. Because when a computer reads ones and zeros, it's basically like many ones and zeros can make a letter, like hello. Lots of ones and zeros can make pictures. More than that can make many video games. All the pictures, all the algorithms, and stuff like that. That's basically ones and zeros. In summary, a 1 is basically the up arrow, which has a signal or has electric current in it. And the one which just goes down arrow is the 0, which no charge at all. So yes, computers can put these together to form letters and numbers, and basically many ones and zeros can make letters, big letters and small letters. In the next part, I'll be teaching how these work together when I come to a computer hard drive. So this is a byte, or yes, this is a byte. A bit is just a single 0 or 1. And in English language, well, this an A is equal to this combination, lowercase a is equal to this combination, and so on. So basically, this is basically it. It's basically the computer's way of transferring one A from another computer to one computer. Since they cannot just say to another computer, like us humans, A. You cannot just say 1 plus 1 is equal to 2, just like we do to someone else. They have to take that information, convert it into zeros and ones so other computers can understand it, and then, well, basically translate it to us humans using some CPU, which is we already explained. So yes, well, how does a hard drive even work? Well, this is basically done by cramming lots and lots of ones and zeros together. This is known as areal density. And a modern hard drive has an areal density of 600 gigabits per square inch, around 300 million times bigger than the first IBM computer used. 300 million times bigger than the first IBM hard drive, which was as big as a room and generated so much heat and electricity to use. So here's the next part. One of the first computers, or not really even a computer, they're basically as big as a desk. That's how big they are. Or maybe equivalent to around 10 gaming PCs. That's how big they are. And they had hard drives, okay? Well, most of them. Well, actually all of them. Some had SSDs, but those are for NASA level. If you had the money, you could use SSDs back then, but they were very little. They had their size. They couldn't store as much data as hard drives. They could only store 1 megabyte, which is 1,000 times smaller than a gigabyte. That's basically it. So yes, what the hard drives use to get that data and read it, or even store that data, is this. It's a copper wire. Well, not exactly. This is a ferro-inductive read and write head, and this was invented in the 1970s in order to shrink the hard drive down a bit so it could fit in a computer 10 times bigger than a gaming PC, and shrink it by 10 times, the hard drive itself and the computer itself, over time. So they used a copper wire, and in that copper wire there was the electric signal. And this electric signal, when a hard drive was spinning, if there was an electric signal in that, let's say there's a second, let's say I do a tap. And in that tap, I give electric signal. That means it's stored as a 1. And there's another tap, let's say I tap again, but in that tap there is no electric signal. The computer would store that as a 0. So this was basically it. Well, not exactly a tap, but when the hard drive was spinning, this thing would give an electric signal. An electric signal equals a 1. No electric signal equals 0. And in that time or space, if it didn't give electric signal, this would be stored as a 0. So that was basically it. And this one is basically a more shrinked version of the hard drive's read/writer head. And over time, it became smaller and smaller, enough to fit into a normal hard drive, which we have in our computers today. So this also led to the shrinking of the hard drive. By tuning out the unwanted electromagnetic signals and basically making the electromagnetic signals more clearer. That way they could shrink the hard drive itself. And if you want, making it have more storage. That's basically it. It's basically fine-tuning the hard drive by getting rid of the unwanted signals. That's basically what shrinking the hard drive did. On the left, we have a 40 terabyte hard drive, and on the right, we have a 2 terabyte hard drive. Well, what's the difference? Mainly, the one on the right has a farther read and write speed. What this means is that the hard drive is going to be spinning faster than the one on the left, even though it's 40 terabytes. This one, when the hard drive spins faster, it's able to read and write things faster. Kind of like a pencil. The faster you write, the more you could put out in the time.